Hi all. Today's gonna be really fast. Actually, this week will be really easy, hopefully. There are 3 more naming rules left, which will perfectly cover this week. And then we're gonna do chemical reactions and a little bit of stoichiometry, and then we're done. I don't know if I'm going to do videos all the way through till technically the end of school. Maybe, because I really want to do stoichiometry. But naming rules, chemical reactions, stoichiometry, and that's the rest of this year. Okay, so there's 3 more naming rules left. The first one's naming with transition metals, and then with polyatomic ions, and then naming acids. Also, in all of these, I'm going to review not just like today we're going to transition metals. I'm just going to do practice with transition metals, but there's going to be the other 2 in there as well. So transition metals, where are they on the periodic table? Hopefully you remember, but if not, they are all of these guys in here. These guys for sure, but also well, all of these, technically even these ones that are under the staircase. These are all transition metals. Now, if you look at these, all of them, almost all of them have multiple charges. I don't know if I can erase. There's only like a couple that only have one. I did not circle aluminum. Aluminum only has 1 charge. Aluminum does not need Roman numerals. But look, like these 2 only have 1 charge, but the rest, a lot of them, there's multiple charges on here. So, there has to be a way to say which charge you're using, and that is Roman numerals. That's what, ready. So Roman numerals in the name of a formula tell the charge of a metal. So real fast refresher, 1 looks like an I, 2 is 2 I's, 3 is 3 I's, 4, 5, 6, 7, 8. It's not going to be any more than 8. In fact, I don't even think there's an 8 on there. So I stopped at 8. 9 would be IX and 10 would be X. But, 8's the magic number for valence electrons. So it's not going to be any more than 8. Okay, now the back of this chart. So if you look right up here, monoatomic ions, this is by no means all of the things with all the elements with Roman numerals, but if there's a Roman numeral next to it, that means you have to use it. Polyatomic ions, this is what we'll do tomorrow. So, but mono, 1 ion. If you notice, silver doesn't have a Roman numeral because silver is always a 1. If we go back to the periodic table, go. Look, silver, Ag, right there. It's only got a 1. In fact, zinc, cadmium, gallium, indium, like all of these guys, they only have 1 number, so they're not going to need Roman numerals. So if there's multiple numbers, they have to have a Roman numeral in their name. Okay, so there we go. Tomorrow is polyatomic ions. Okay, so now examples. So you don't have to look up Roman numerals. You don't have to look up the charge. These are all ionic compounds, so you have to look at charges. Ionic compounds look at charges. But with the Roman numerals, that means you don't have to look it up. So chromium, the 3, means chromium is a 3 plus. I should pick a lighter color. Okay, so I'll erase that. Oh, come on. 3, there we go. All right, chromium is a 3 plus, and you have to look at your periodic table for what sulfide is, but sulfide's a 2 minus. So what's the formula? Remember, you switch the charges once you get them. So it would be Cr2s3. Nickel chloride, again, that's the charge. So nickel's a 2 plus, chlorine's a 1 minus. So the formula, switch them, Ni, no, you don't write once, Cl2. Lead 4 oxide. This one's tricky. Lead is a 4 plus. Oxide is a 2 minus. And if we follow the just switch the charge rules, you get Pb2O4. Well, technically that's not right. Ionic compounds are going to combine in the lowest ratio. So really the formula is PbO2. So, I mean, if we were actually in class and you would ever do that, I would take off a whole half point for getting that one wrong. Last example, manganese 3 phosphide. Manganese has the 3 charge. Phosphide has the 3 minus charge. So it's just, and manganese is Mn, and then phosphorus is P. No extra numbers because they cancel each other out. So there's the writing formulas. And now names. Now this is where it gets just a teeny weeny bit tricky. In order for you to know the charge of the metal, you have to look at the charge of the non-metal. So this one, okay, so oxygen, so all of these, anytime you have these metals, you have to look at the charge of this guy. Oxygen has a 2 minus. So funnily enough, that's why that 2 is there. So if this 2 moved here, what does that make the charge of the iron? It's like a reverse switch. 2 goes up there, that means the iron's charge is a 3. The harder way to do it is to do like this little dot, and you know charges cancel. -2 times 3 would be 6 minus, this side would have to be 6 plus. 6 plus divided by 2 is 3 plus. You multiply going down, divide going up. And again, that's trickier. So the name, this charge is a 3 plus. So the name is iron, and then you put Roman numeral 3 in parentheses. Oh, I probably completely forgot to say that. The Roman numerals are written in parentheses. And then oxide just keeps its name like always. You know, the oxygen changes to ide. Copper chloride. It's copper chloride. We don't know the charge yet, but chlorine's a 1 minus, and there's 2 of them. So that means this has to be a 2 plus. So this guy would be copper 2. Oh, not 2 like that. Psh, I. And technically it has a lines above it, but like I'm not gonna I copper 2 chloride. So maybe I should add up here the note again, and this one would be. So how do you write the names? You have to look at the charge of the nonmetal. Look at the charge of the non-metal to find the charge of the metal. Okay, there we go. I'm going to go back to this yellow. Okay, so P, phosphorus, is a 3 minus, and there's only one of them, so that means in order to cancel out, this has to be a 3 plus. So name, nickel. I don't know if it's EL or LE. I spell it wrong every time. We'll go with that. It might not be right. Again, 3 phosphide. And then last one, sulfur is a 2 minus, and the 2 went there, so also then that means this is a 3 plus. So bismuth, BISMUTH, I think I spelled that right, bismuth 3 sulfide. Oh, I did a lot of 3 charges. Let me do one more that's not a 3. Let's do CuCl, which is no extra numbers. So chlorine's a 1 minus. That means this copper is a 1 plus. So this guy's name is copper 1 chloride. Okay, there you go. We're going to do 4 practice of each for the draw it. So hopefully that was really easy. We'll see you guys tomorrow.